Now let's analyze another important system register for exception handling. That register is ERR EL1 register. Unlike VBAR EL1 register, the ERR EL1 register is updated every time exception happens. So another system register like FAR EL1 register or ESR EL1 register is also updated every time the exception occurs. From the debugging perspective at low levels of the program, those three registers are extremely important. When you go through the crash issues or exception issues, you will check the value of this system register. Now let's review the ARM reference manual that describes ERR EL1 register. So ERR EL1 register means exception link register. In the real project, some system software engineer call this register as exception link register. The main purpose of this register is to hold the return address when the exception happens. Remember that when the exception is taken to exception level 1, this register, ERR EL1 register, is updated. When the exception is taken to exception level 2, exception level 1, the ERR EL2 register is updated instead of ERR EL1 register. Since this register holds address of instruction that cause exception, so many of the system software engineer refer to the value of this system register. So from debugging perspective, this register is extremely important. Now that we understand the ERR system register, let's look at this sample assembly instruction to read the value of the ERR EL1 register. So as you can see, this is the MRS assembly instruction. As you know, if you run this assembly instruction, the value of this register, ERR EL1 register, is written to any of the general purpose register. So in this situation, X22 is the destination register for this assembly instruction. So this assembly routine is the part of exception handler. What I mean is that after exception happened, ARM core update the value of ERR EL1 register. As you know, since this register holds the address of the exception, so the value of this register is mainly and checked in the exception handler. So another important thing is this register, ERR EL1 register, is usually updated inside ARM core. That means at the hardware level, ARM core update value of ERR EL1 register when generating exception. Now another important key point is when this register is updated. So here is the diagram that explains how exception is generated step by step at the architecture level. So as you can see, there are 4 steps to generate the exception. So when the memory overload occurs in the first stage, ARM core will generate exception. So this box from step 2 and step 3 indicate the operation at the microarchitecture level. The microarchitecture level means the sum of the operation can happen at the hardware level. That means it is impossible for us to see any of the assembly routine to see how this operation works. So during this operation, as you can see, ARM core update several system register. Among these, ERR EL1 register is updated. Once this job is done, the program counter moves to the exception vector address. Right after program counter moves to exception vector address, the corresponding exception handler will be called. But at this moment, the software can read the value of ERR EL1 register to determine the address of causing exception. Let's know this workflow will show you when the ERR-EL1 register is updated. That means during generation of exception, ARM core update ERR-EL1 registers at the microarchitecture level. For this, it is extremely important to check the value of ERR-EL1 register for debugging purpose. So ERR-EL1 register is used as for another purpose. That is to perform exception return. But usually, from debugging perspective, system software engineer mainly refer to the value of ERR-EL1 register because it will tell you the address of causing exception. So now that we understand ERR-EL1 system register, next lecture we will explore another important system register, that is FAR-EL1 register.